The Electromagnetic Compatibility tutorial is an EMC education on a CD-ROM. It covers a broad range of topics that are targeted for users that are new to the field of EMC, as well as to seasoned EMC engineers. As products continue to become more complex with ever-increasing speeds, attention to EMC is no longer just a regulatory requirement to market your product. Attention to EMC has become synonymous with good engineering design practices that improve the functionality and quality of your product. The EMCT provides over 1,200 screens in color using mixed media. There are 3D animated graphics, photographs, plots, schematics, and block diagrams. The presentation window of EMCT can be made as large or small as your computer monitor will allow. In this tutorial, the author weaves the concepts of EMC into a powerful understanding of complex systems, one simple layer at a time. The teaching method is both conceptual and intuitive. Throughout this tutorial, you're provided with numerous design examples and the design rules. And what's most important, you're not just blindly learning a bunch of rules. Always, you're learning the concepts, so you'll know when and where to apply the design rules. Many topics in the EMCT provide additional screens to clarify and further explain the concepts. This additional information is contained within sub-tiers that are accessible from the main screens and the table of contents. Along with the new modules, several enhancements to the entire EMCT have been made. The screen resolution has been increased and the screen navigation options have been expanded. In addition to clicking on the navigation buttons, now you can just slide the navigation bar to a particular screen and you're there. You're now able to jump to a selected topic from the module and section-specific table of contents. In addition, a comprehensive and unified index allows you to jump to topics anywhere in the tutorial. Topics in the index are listed to help you navigate to specific areas of interest. For example, all the rules have been listed under the category EMCT Rules. Perhaps you'd like to jump to the electromagnetic field animations. These are all listed under the category EM Field Animation in the index. Or would you rather navigate with your keyboard? In addition to your mouse, EMCT now allows you to use your arrow keys. This is the main menu. It contains access to the Introduction module, the Propagation module, the Design module, and the Shielding module. Access to these modules is granted after the purchase and authorization process are completed the first time you launch the program. This is the Introduction to EMC module. It contains over 40 screens. The Introduction module is intended to familiarize you with an overview of the concepts involved in the discipline of electromagnetic compatibility. This module will prepare you for the presentational approach used in this tutorial. If you're unfamiliar with EMC processes, the Introduction module will initiate you to the descriptions and preliminary explanations. If you're already well versed in EMC concepts, this module will introduce you to the presentational and descriptive approaches used throughout the program. This is the Propagation module. This module contains 3 sections with over 370 screens. With the Propagation module, you're introduced to the primary mechanisms that create EMI from active circuit boards. Using a layered teaching approach, you'll first learn about the fields that are created by a single device. Then, building upon those concepts, you'll be able to understand the more complex fields that emanate from several devices, including how circuit boards couple EMI currents to attached wires or cables and form radiating antenna structures. Along the way, you'll learn the Fourier approach, that digital waveforms are comprised of many higher frequency sine waves. You'll learn how circuit boards create distributed transmission lines with respect to chassis structures and surface planes. You'll learn how to control EMI propagation using the reflection losses and null formations that form within the distributed transmission lines that are set up between the boards and the chassis. Then, you'll learn how to minimize losses by flux and inductive cancellation using transmission line methods in the stack-up of circuit boards and individual traces. Finally, you'll study the techniques needed to reduce EMI coupling by partitioning the circuitry. By the time you've read and mastered the propagation module, you won't need the hand-me-down list of do's and don'ts in PC board design. You'll be able to create your own, specific to your particular products. This is the design module. This module contains 5 sections with over 490 screens. The design module begins with the relationships between stacked, coplanar, and parallel circuit boards. In detail, you'll examine the coupling effect on interface connections, the common mode losses of interboard connectors, and the slot antenna structures that are created among the boards. You'll learn about the resonance interactions among stacked and interconnected products. You'll examine the common mode effects on EMC in products with motherboards and perpendicular peripheral boards. You'll learn about the interface effects of common mode loop structures with the chassis, bus cards, and motherboards. Next, you'll take a look at larger scale products. You'll examine the backplane architecture and bus structures of perpendicular cards. Then, you'll learn about the relationships of common mode currents and fields between circuit boards and the backplane. After you have a good grasp of these relationships, you'll turn your attention to the effect these common mode currents have on the EMC performance of interconnections, such as data cables and wiring to the power subsystems. From interconnections, you'll move to common mode loop structures and study the resonance and field transfers of rack-mounted card cage subsystems. Finally, you'll learn what happens when mid-plane configurations are used instead of backplanes and learn about the potential EMC advantages of partitioning a system using mid-planes. The design module concludes with a brief discussion of the overall system susceptibility. This is the shielding module. This module contains 4 sections with over 330 screens and examines several product shielding strategies. You'll learn how shields function with regard to enclosures, localized shields, and cables. In particular, you'll explore the demands placed on shields at increasingly higher frequencies and shorter wavelengths. You'll begin with a look at the broad concepts of how shield structures function in terms of losses and shielding effectiveness. Next, you'll examine the effects of the incident wave impedance on the performance of a shield. Then, you'll investigate the effects from gaps, seams, slots, and perforations. You'll learn how to use waveguide apertures in a frequency mode below cutoff, and study apertures, gaps, and perforations as phased array structures. Then, you'll learn how to use localized shield structures. Next, you'll examine circuit partitioning methods using board-mounted shields, and in particular, learn how to use segmented shields to offset the performance required of a perimeter shield. Finally, you'll apply shielding and partitioning strategies to shields on cables. You'll focus on cable shield characteristics and termination methods as the completion of a perimeter shield structure. As you've probably concluded from this brief demonstration, electromagnetic compatibility engineering is somewhat complex. It takes a particular mindset to effectively work in a science where none of your senses can directly detect the source. EMCT is intended to fortify you with a good dose of understanding EMC concepts and good design practices. Speed is not important, so don't race through the material in EMCT. Be patient and allow the concepts to be absorbed.